Good morning and welcome back to NASA's Johnson Space Center for today's mission status briefing. It's flight day 11 of the STS-134 space shuttle mission to the International Space Station. And for an update of, or a recap of today's activities on board the shuttle and station complex, we have the lead space station flight director for the flight, Derek Hausman. Again, we'll start out with opening comments and then take questions. Derek?
Okay, thanks, Kylie. Good morning, everybody. Well, as Kylie mentioned, we're just wrapping up flight day 11. As I was leaving the control center, the folks in the station side were just starting their evening daily planning conference with Ron Guerin and the rest of the station crew. We started out today with docked late inspection. And of course, the shuttle crew uses the space shuttle robotic arm, grapples the orbiter boom sensor system, and then uses that OBSS to inspect all areas of the shuttle thermal protection system. The crew actually got started early on that procedure and thus finished early, which was a great help on a pretty busy day. It allowed the EVA crew that's going to be conducting EVA 4 tomorrow to get started on their preparation activities a little earlier. The dock late inspection procedures were completed all nominally. The data is all on the ground. The expectation is that by the 1 o'clock MMT here in Houston, that there will be a discussion of the preliminary results, and the expectation is that within the next 18 or 20 hours that all the imagery will have been analyzed, and the expectation is that we'll clear the vehicle, give it a good, clean bill of health in terms of the orbiter TPS. You may recall that the reason that we're doing this docked late inspection as opposed to the typical late inspection, which is scheduled post-undock, is that on EVA 4, we're actually taking the OBSS from the orbiter and stowing it on station where it will remain for the life of the station. And I'll talk some more about that when I get into the EVA 4 details. Additionally, today, once that dock late inspection is complete, Greg Shamatov continued his work on the oxygen generation system on station. We talked in my briefing 2 days ago about the fact that Shamatov installed a filtration cartridge and some plumbing associated with that cartridge on the oxygen generation system water loop in an effort to clean contaminants from that system. Today, Taz did a final leak check of all the connections he made, verified no leaks, and he went ahead and closed up the rack and buttoned up the system. Now engineers and flight controllers on the ground are going to reactivate the oxygen generation system and assess the performance of that filter cartridge. Let's see, in addition, of course, the EVA 4 crew plus Drew Feustel, who will be their IV, or the person orchestrating the spacewalk from inside the station, prepared for their EVA. Part of that preparation was swapping out the EMUs. So at the end of the day, we'll have Mike Fink's EMU and Greg Shamatov's EMU both in the airlock, ready to go for tomorrow's EVA 4, and then Drew Feustel's EMU, which he's done with for this mission, is in a configuration to return on the shuttle. In addition, of course, to the setup hardware, they did the procedure review, and they also got their tools reconfigured and ready to go. And as I was leaving the control center, the EVA crew was well ahead of the timeline and just doing their final procedure reviews and discussions before we put them to sleep for the night. Additionally, as we discussed yesterday, we plan to use the camp-out protocol for this EVA, and that's primarily due to the issue that we had on EVA 1 relative to Greg Shamatov's carbon dioxide sensor. So we're going to put Mike Fink and Greg Shamatov in the airlock overnight, and then in the morning we'll repress the airlock, bring them out, give them time for breakfast and personal hygiene, and then get them suited up and ready to go. In terms of EVA 4, just looking ahead to that tomorrow, as I said, the first activity involves actually stowing the OBSS on the station S1 truss. So the OBSS will be positioned by the station robotic arm in a position that Fink and Shamatov can actually grab it and place it on stanchions on S1. Once we do that physical connection on the S1 truss segment, the EVA crew will translate to P6, where they retrieve a power data grapple fixture, or PDGF, that's not in use. We'll bring that PDGF back to the OBSS, remove the existing grapple fixture, which is designed to interface with the shuttle arm, and replace that EFGF, as we call it, with a station PDGF, which can then be grappled by the station arm. At the into the EVA, once all the OBSS-related tasks are completed, we're doing some work on one of the spare SPDM arms that we actually launched on ELC3. There's fasteners on those arms that we're concerned with the thermal cycles on. The spares on the external truss of the space station naturally expand and contract as the thermal environment changes, and past experience with these particular fasteners has indicated that these type of thermal expansions may cause wear and tear on whatever piece of hardware is associated with these fasteners. So we're going to remove those from the SPDM arm in order to protect it down the road and make sure that it's not damaged as it waits on the truss for potential use in the future. And I think, Kylie, that's it for an overview if you want to take questions.
Okay, we'll start here in the room. Go ahead.
Hi, Rob Perlman with CollectSpace.com. With a couple of questions. First, I realize this is a shuttle side thing, but I think I heard a call about the shuttle crew having an issue with their WCS and maybe with the using the station's WCS as well. Do you know what that was about and what the situation is?
Yeah, the conversation probably related to which shuttle crew members were actually using the station WHS, or basically the station toilet. When we fly the shuttle missions to station, we have a pre-planned mix. X number of shuttle crew members use the station and vice versa, and it's basically a balance between the two vehicles. And based on what we've seen over the past several days, we made a decision to move all the shuttle crew members over to station. So that's probably the conversation that you heard. I'm not familiar with any issues on either vehicle relative to the WCS.
With regards to the CO2 sensor in Greg's suit, were it to fail while they were still in the airlock in preparation to go out for the EVA, would that mean an end to the EVA altogether, or would you come in and try to reset it as it did before, or what would be the situation in that case?
Yeah, I'll say first that we know the issue with the sensor is moisture, which obviously increases as a crew member works in his suit in terms of perspiration. So, I would say based on the failure mechanism, it's unlikely to fail early. But if it did, we would press with the EVA. What we've done, we know the capability of the lithium hydroxide cartridges on the ground, and we've picked a LiO cartridge with maximum capability, because they're not all created equal. It depends on how they're packed and manufactured on the ground. So we picked a cartridge with maximum capability put in Greg's suit, something on the order of 7.5 hours, maybe more than that, so that if we were to fail that sensor and we had to deduct the capability based on the failed sensor, he would still have enough left to do the 630 EVA. So we'd press without it, and as we talked before, we'd depend on Shamatov to give us indications of any CO2 system, but we'd have the capability to complete a 630 EVA.
Mark Carreau for Aviation Week. I wondered on the inspection today, it didn't sound like anything jumped out, though I understand you have to really go through the data. Looked like, from what you could see on the surface, that there wasn't new damage.
I agree. It looked like a pretty clean TPS today.
Denise Chow at space.com. Allison, I think, talked about some things that could be done, just very preliminary, to flush out the CO2 sensor. I know it can't be swapped out because the procedures aren't there, but was anything done in between EVA 1 and now? Anything done to the sensor?
Yeah, we ran what we call a dry out procedure, where without the crewman in the suit, we configure it such that we flow oxygen through the suit and past that sensor. And as a matter of fact, when we powered up the suit on that day after, the sensor was already clear and had a nominal reading. So on its own, it had already dried out enough to recover, but we went ahead and ran that dry out procedure just to get some additional margin there.
And also, how important is it that all the procedures for EVA4 are completed, because this is the last EVA that's going to be conducted by a shuttle crew?
Let's see, on the OBSS portion of it, of course, the most important thing is that we get the boom handed off because and stowed on station. Otherwise, the boom goes back on shuttle, and that's a significant impact. You'd have to look at 135 or perhaps not do the boom stow at all. Once we get the boom stow on station, the actual retrieval of the PDGF from the P6 segment could be done at a later date, in theory, by a stage crew, for example, without the shuttle present. The fasteners on the SPDM spare arm that I mentioned, because that's a thermal cycling issue, and it's ongoing now as the station goes through its orbit, there is some importance to getting that done sooner rather than later. So if we were not to do that task, these EDF fasteners on that SPDM, that might be something that's considered for STS-135, perhaps. It'd have to be weighed against everything else that's planned. But the power and data grapple fixture in particular, with no near-term use for the OBSS, no specific use, we could live without that PDGF for some amount of time.
Okay, now we'll start with questions on the phone bridge. Charles Atkinson, please.
Good morning, Charles Atkinson, based on newsexaminer.com. I was wondering if you could discuss the issue with APU-2 yesterday, and will it be operational for landing?
Yeah, unfortunately, I'm not prepared to discuss the details of the failure. I can tell you that it was a redundant heater on a different APU than we had the issue with pre-flight. So no changes in procedures required, and we still have a fully functional redundant heater string available to us.
So you feel very confident going into landing with this APU, or is it going to be tested the day before landing?
Yeah, we'll manage the system the same. No changes the way we're managing that heater system in the APU, and with a single heater, we still have all normal capability. There's no issue with freezing the lines or any of the other things that were discussed pre-flight. And the failure the failure that we did have was intermittent. So we know for sure that we've got a good redundant heater string.
Okay, thank you. And one last one. I was wondering if you could step back for a moment and share your own thoughts on Friday's final Space Shuttle crewed EVA. Will you keep a few NASA spacesuits also on the space station?
Yeah, and starting with your last question first, we'll maintain a EVA or spacewalking capability on station for as long as station is on orbit, and we can do all the things that we can do relative to an EVA station only without a shuttle as we can with the shuttle. Of course, the airlock is there; it stays with the station. We'll have enough EMUs to support two-person EVAs. We have all the tools required. We are actually building up an inventory of spare parts for the EMUs, such that we are in position on station to do maintenance on the EMUs that to this point we weren't able to do. A good example is this CO2 sensor. We mentioned after EVA 1 that we have a CO2 sensor for a EMU on board, and that the procedures were in work but weren't ready. And that's an example of the capability that we're building up to. Instead of flying the EMUs home to be refurbished and repaired, we're going to have the spare parts and the procedures and the techniques ready to go on orbit in order to protect that capability. And on station, there's a number of critical components that require a pretty quick reaction, a reaction in terms of maybe 10 to 14 days in order to protect the station. Things like the external thermal control system, main cooling pump, certain key components in the power system, so that what we plan to do is preserve the capability on station to stage a spacewalk to change out one of those critical spares within that 2-week window. So short answer to your question is we'll continue to do EVAs from station, and we have all the capability that we have during a shuttle dock mission. And that your first question, when I started working the station program, it was well before STS-88-2A when we launched the first U.S.-built piece of hardware, the Node 1 module, and we were in that redesign cycle, if you will, where every couple of years there would be new ideas, new thoughts. Perhaps we had to scale back or change the design, and you know, in that kind of period, it can get a little discouraging, and you kind of start wondering if and when we're ever going to fly real hardware. But you know, once we hit the ground with STS-88, launched the node module in 1998. Looking back at what the station was then, two relatively small pressurized modules without a capability to support people, to what it is now, this just huge, amazing laboratory with the ability to support 12 people for short periods, to support 6 crew members long term, and the spacewalks that we accomplished. We have come a long, long way, and it's an amazing capability that we've built, and I'm just proud to have been a small part of it.
Okay, and just briefly to confirm, you won't rely on just the Orlan suits. You'll be using American NASA EMUs?
Yes, that's correct. And you know, it's a good point you make. We also have the capability to do EVAs using the Russian airlock and the Russian Orlan suits. We have a separate and independent capability using the U.S. airlock to stage EMU-based American EVAs, if you will. So, I mean, it's an EVA that would look exactly like the ones that we've been doing this dock mission, except the orbiter's not docked.
Thank you so much.
You're welcome.
Next is Philip Sloss.
Philip Sloss with NASASpaceflight.com. Following up on Charles' question on Greg's EMU, is for future EVAs that might use that EMU, is there any thought, maybe in the short term, to preemptively doing a flush of that sensor before you would go out to do that?
Yeah, that's certainly one option. I would tell you that my expectation is that once we get this dock mission behind us, is that there'll be a lot of focus and emphasis on the procedure that we're developing to change out the CO2 sensor. So we do have a spare on orbit, and the procedure needs work, needs validation, needs analysis, but I would expect that to be the focus over the near term, to get that procedure ready to go and at some point have the on-orbit crew change out that sensor.
Okay, thanks. And do you have any general status on how transfer is going, and also the status of the Cedar work?
Yeah, the Cedar work is actually is going very well. I told you, I guess 2 days ago, that the crew was able to remove the Cedra hardware from the rack in which it's normally mounted, and we moved the Cedra, their carbon dioxide removal assembly, to the GEM module, which is a good workplace. On the timeline tomorrow is a number of hours of work to remove the bed or the cartridge that does the actual CO2 absorbing. We're going to remove that cartridge from the Cedra unit. We're going to replace it with a cartridge that we brought up on this flight on ULF 6, and then we'll actually wrap that up and reinstall the Cedra in its normal location. And I said tomorrow, it's actually flight day 13, so it's the day after the EVA, because Taz and Spanky are doing most of that work.
Okay, thanks. That's all for me.
And on the transfer question, going very well. I don't have the specific numbers, but we're ahead of schedule, and then flight day 13 and 14, we wrapped that up.
Thanks.
Okay, next on the line is Marcia Dunn.
Yes, hi. Derek, do you have any idea what set off that smoke alarm a little while ago?
Yeah, that's a good question. I didn't mention that, but that was a little excitement in the middle of the night. What we had was an onboard alarm and then an indication on our caution and warning panel that one of the 4 smoke detectors in the service module was in alarm. Looking at the data, it was quickly obvious that the other 3 smoke detectors in the service module were not showing any indication of smoke, and then the Russian crew called down per procedure and per training to report to MCC Moscow that there was no visible smoke and no burning smell, which are the key pieces of information that we try to get from the crew. In addition, in that call, the crew reported that they were working in a compartment in the service module where that smoke detector is mounted. So what we assume happened is that there was some dust kicked up by the crew's work in that area that obscured the sensor briefly, looked like smoke, and caused the alarm, which is something that we've seen in the past. The fact that none of the other 3 smoke detectors showed any indication of smoke. In addition, you know, the nearby U.S. modules also didn't show any indication of smoke, allowed us to pretty quickly call it a false alarm and get the system back in a nominal configuration.
That's all from me.
Okay. Next is Todd Halverson.
Thanks very much. Derek, you guys are about to declare victory on assembly complete of the USOS, and I'm wondering if you could compare this accomplishment to or rate it among other human engineering achievements. Thanks.
That's a tough one. It's tough because I'm biased, having lived through it and having participated in most of it. But when you consider the capability that we've developed and just the amazing things that you can do with this laboratory that we have on orbit now, the numbers of folks that can be supported, our ability to repair it when it breaks, the potential that it has, in terms of science and payloads and other things, I think it's got to be right up there. I mean, for me, the Apollo moon landing will always be the pinnacle for whatever reason, just my personal perspective. But I would certainly put the space station right up there with anything else we've accomplished.
Thanks. That's all from me.
Okay. And finally, Irene Klotz online.
Thank you. I have a question about this final shuttle-based EVA. In light of the station, of course, maintaining capability to do EVAs, what's the significance from the station's perspective of having this be the last one?
Let's see, I'm not completely sure I understand the question. Are you asking why we're doing another one on 135?
No, I'm asking from the station's perspective, is it a big deal that this is the last shuttle-based EVA? Do you get something out of the shuttle crews, aside from extra hands, of course, that you don't get from doing the EVAs on station?
I see. Yeah, one of the differences between a shuttle dock mission EVA performed by shuttle crew members and a stage EVA performed by the station crew is that we have, over the 2 years leading up to a shuttle dock mission, we have almost continuous access to the shuttle crew and to the spacewalking astronauts. So we go through a very extensive and very intensive training process. So as an example, for the 4 EVAs we'll have conducted on this dock mission, each of the crew members will have practiced the details and gone through the procedure in the neutral buoyancy lab on the order of 5 or 6 times for each EVA. In addition to the neutral buoyancy lab training, they will have done procedure walkthroughs and other tool familiarization. So, they have worked for multiple years to prepare for the specifics of the EVAs that we're going to go do on this mission. Now, when you contrast that with the station crew member, they have the same generic training. So they have the skills required to do the spacewalk. They practice generic tasks in the NBL. They have all the same generic training, but they probably won't have done the EVA specific training that a shuttle crew member will have done. So as an example, when I talked about these significant failures on station that we must respond to, part of that 2-week response period is getting the station crews up to speed on whatever task it is that they have to go execute. So I would say that the shuttle crews have much more flight-specific training. In the end, the capabilities are identical. The station crews are going to have all the same basic training that the shuttle guys do. It just takes a little more time on orbit to prepare them for whatever task it is that we're going to ask them to go do.
Thanks. Also, just want to follow up something from yesterday. You said that you thought that shuttle legacy shot would be available in about a week, which is probably 5 or 6 days later than I think what we were initially told, and probably 7 days later than what we all want. But do you have any updates on the recovery of that disk and the distribution of the images?
No updates from what I told you yesterday. What I've been told is that the photographs are in the Soyuz, moving to Moscow along with all the other cargo, and then they'll be processed just as the rest of the cargo is. And then at some point we'll have access to those photos.
Thank you. And on the UBSS transfer, I think I know the answer to this, but I want to hear it from you. The reason why this is being done on this mission instead of 135 is because of the EVA?
Yeah, you know, with our capability to do 4 EVAs and the OBSS work essentially consuming an entire EVA, this is the flight that made the most sense. One of the things that they're going to do on 145 is bring home the failed pump module, and you can't, it's really not practical to do both, the OBSS and the pump module. So 134 just made the most sense in terms of time allowed and numbers of EVAs.
Thanks very much.
Okay, that's all on the line. Are there any follow-ups here? None. We will wrap up today's briefing with some programming notes. There was a joint crew news conference early this morning with all the crew members on board the shuttle and station, so that will be replayed at 9:30 a.m. Central Time. And then the crews go to sleep shortly, so there will be a video file at 11 a.m. And then the flight day highlights will begin airing at 12 p.m. There is a Space Station Flight Director update at 4:45. The crew then awakes for the next day at 6:56 p.m. And again, that's for the 4th and final spacewalk scheduled for this mission, which is scheduled to start at 11:46 p.m. this evening. And we'll go back to Mission Control. Thank you.